All right, let's talk about the word power. We throw it around all the time, right? We use it to talk about strength or influence. But in the world of physics, it means something very, very specific. And it's probably not what you're thinking. So today, we're going to get to the bottom of what power really is. To get our brains warmed up, let me ask you this. You've got a weightlifter slowly but surely hoisting 200 kilograms over their head. And then you've got a sprinter exploding off the blocks in a 100-meter dash. Who's more powerful? Go with your gut. Lock in your answer, and we'll circle back to this in a few minutes. Now, before we can really tackle power, we've got to lay a little groundwork. We have to start with one of its most important building blocks, a little concept from science class you might remember called work. So, in physics, work has nothing to do with your 9 to 5 job or doing chores around the house. It's got a super precise definition. See, work is only done when a force actually makes an object move. If you push against a solid brick wall with all your might and it doesn't budge, you've actually done zero work. But the second you push a box and it slides across the floor, boom, you've done work. And you can't talk about work without talking about its partner, energy. The best way to think about energy is that it's the currency you need to spend to do work. It's the stuff that lets you apply that force in the first place. So really, doing work is just the act of transferring energy from one place to another. They're two sides of the exact same coin. Okay, so we've got work and energy sorted out. Now we are ready for the main event. Let's see how these two concepts come together to give us the true meaning of power. And this right here is the key. This is the big aha moment. Our everyday idea of power is all about sheer strength, how much force you can apply. But in physics, power isn't about how much, it's about how fast. It's a measure of intensity, not just brute force. This little sentence right here flips our whole intuition upside down. Let that sink in. It's not just about lifting the heavy thing, it's about how quickly you can lift it. The time it takes to do the work, that's the secret ingredient. So here it is, the official definition that pulls this all together. Power is the rate at which work is done. That word rate is everything. It's asking how much work are you doing or how much energy are you transferring every single second. So how do we actually measure all this? Well, like with most things in physics, we can boil this whole idea down into a beautifully simple little formula. Let's take a look. Before we even get into the letters and the symbols, the concept is as easy as it gets. To figure out the power, you just take the total amount of work that was done, and you divide it by how long it took to do it. That's it. Okay, quick rundown of the units we're using. Work and energy are measured in something called joules. Time, no surprise, is measured in seconds. And when you divide joules by seconds, you get the special unit for power, which is the watt. And you have definitely heard of that one before. And here is that beautiful formula, P equals W divided by T. P is for power, W is for work, and T is for time. It's simple, it's direct, and it perfectly captures that whole idea of a rate. But wait, remember what we said earlier? That work and energy are basically the same thing, just looked at from a different angle? Well, that means we can express this relationship in another way. So here's the other version of the formula, and it means the exact same thing. Power equals the change in energy divided by time. That little triangle is the Greek letter delta, which just means change in. So this is just saying power is the rate that energy is being transferred. Same idea, different label. Okay, so that's the physics. But how does this all connect back to our weightlifter and our sprinter? And more importantly, why does this definition actually matter in the real world? We can finally answer the question. The person who was more powerful was the sprinter. While the weightlifter did a huge amount of work lifting all that weight, they did it over several seconds. The sprinter, on the other hand, unleashes an incredible amount of energy in under 10 seconds. Their rate of doing work is just through the roof. They are, by the definition of physics, way more powerful. And once you get this concept, you start seeing it absolutely everywhere. That watt rating on a light bulb, that's telling you how fast it turns electrical energy into light. The horsepower of a car engine, that's just another unit for power. It's all measuring the rate of energy transfer. So I'll leave you with a final thought. The next time you go to charge your phone, take a look at the little power brick you plug into the wall. It has a number on it, followed by a W for watts. It might be 5 watts, or 20 watts, or even more. Now that you know what power really is, what is that number actually telling you about how fast it can fill up your battery? It kind of makes you look at things a little differently, doesn't it?